alike and different about those equations? Tell me something that is alike. Come on, guys. They both have negative numbers, right? These guys are negatives, right? These are negatives. These are negatives, right? What else?
They both have X's.
They both have X's. Okay? How about something that is different? Something that's different. Somebody else.
One of them equals a negative and the other is a positive.
That's true. One of them equals negative, one of them equals a positive. What else?
Only one of them has both positive and negative on one side.
That's true. What else? There's something I want to say a little bit more, Simmering.
And the second one's answer, there are X's.
That's right. This one has X's on both sides versus this one doesn't. So this one, let's write the equation for this. What would this be?
2X plus 3.
What is happening here? 2X, minus 3 or plus negative 3 equals 1. And then what would this equation be? X
plus 4
Equals 2.
I always put my x's first. Negative 3x minus 2 or plus negative 2, okay? And so then we would talk about solving from there, but we haven't learned how to do this just quite yet, okay? All right, so from last night's homework, and again, I know a lot of y'all finished it in class. What can I go over? Number 4, okay? We're just going to rework it. So it might be easier. Okay. So it was 2/3 n plus 4 equals negative 26, right? So I'm going to hold that variable still for a minute and get rid of plus 4. How do I do that? Minus 4, minus 4. So 2/3 n, and then negative 26 and negative 4 would be negative 30. Okay. What's happening with 2/3 and n right now? It's being multiplied. So the opposite would be to divide. But when I divide by 2/3, that's the same as multiplying by the reciprocal, or 3/2. So I'm going to multiply both sides by 3/2. Those eliminate, and all I'm left with is n. This is really 30/1, remember? So this would be 30 times 3, which is 90, divided by 2, 45. But it's a negative times a positive, so that is negative. Also, with your calculator, which I don't see hardly anybody picked up, but that's okay. I think with equations, until we get to these hard numbers, we don't really need it. But if I was to type in 30 times 3/2, I still get 45. Right? I just didn't put my name in it. Huh?
Could you just eliminate the 30?
Yes. What we're going to talk about now is how to solve this equation using our algebra tiles on both sides, okay? So the key is you want to have all your variables on one side only, right? Just like we've been doing in 6th and 7th grade stuff, yes? But right now I've got them on both sides, so I've got to figure out which one that I want to do, okay? Basically, I want you to think about it like a tug of war, all right? And in a tug of war, who always wins? The stronger person, which is usually the bigger person. That's right. So we're going to leave our big guy alone. Think about it like that, okay? Whoever's bigger, we're going to leave him alone, and we're going to move the little guy. So in this case, I want to move my 1x, but I can't just pick it up and move it, right? Just like before. But how can I get rid of it? How can I make him not exist anymore? Because what am I creating? If I bring a negative x in here, what did I just create? That's what I was looking for. I just created a zero here. So go ahead and either do that with your tiles or draw it, whichever way you'd rather. Okay? But what's my rule, my famous rule? What I do to one side, I have to do the other. Okay? So now, can I, with my tiles or with my drawing, eliminate any zero pairs?
Yes.
Yes, right here. that's a zero pair, and that's a zero pair. So my first goal was to get my X's all on one side. Did I do that?
Yes.
Perfect. Now, my second goal is an old goal, which is now I just want X by itself, right? So what's hanging out over here with that? A positive one. So how do I get rid of it? I'm gonna bring in a negative one with my algebra tile. But what's the rule again? I gotta do it to the other side. Okay? And now, do I have any zero pairs? Yes, I can cross those zero pairs out there, and I've got another one over here. Now, do I have X all by itself? Yes, so I'm gonna write that at the bottom. X equals, and what's the only thing left over there? One. Okay? Now, I know, well, first of all, I do think the models are kind of cool, because you're like, well, it actually works, right? But are we gonna use the models all the time to solve? Why not?
Because the numbers are gonna get bigger.
Exactly. It does take too long, the numbers are gonna get bigger, and they're also gonna get more difficult with decimals and fractions. So I'm not gonna always be able to use a model. So we want to learn algebraically. So over here, we're gonna work this exact same problem that we just did. Okay? But this time, I'm going to draw. I know you might have already drawn, but I'm gonna draw so you'll have a record on your paper. So if you didn't draw it with me, okay? First thing I need to do is I need to write down my equation. So what's on the left? And do I need to put a 1 in front of my X, or can I just put X? I can just put X. So X, what? Plus 2 equals. Perfect. And I'm still going to put my line here, just because that's what we did on the model. Okay? Okay. So we said we want to move our variables first. And we said, like tug of war, we're going to leave the big guy alone, so we're going to move this one. So to get rid of a positive X, we brought in a negative X, right? And then we did that to both sides. Over here, though, algebraically, what are we actually doing? We're subtracting X from both sides. Is that the same as bringing in a negative X? Yes. Okay. Here, we created that zero pair, so we marked it out. But here, I can mark it out if I want to, but I don't have to. I'm just going to bring down what's left, which was 2. And then 2x minus 1x is what? Just 1x. But don't forget to bring down the plus 1. And now here is where we were at our regular old equation, where we brought in the negative x over there. And so I needed to do the same thing on the left, which was a zero pair. Remember, we did that. But on my algebra, what do I do? Minus 1, minus 1. You're left with only x equals 1. And isn't that what we got over here? Yes, it totally works, okay? The number line, don't forget, I need a 0, I need a 1, and what goes on it? A dot, right? The dot goes after 1. If you have, looks like I'll have a little bit more space. One thing you might want to do finally is plug in 1 instead of here to check. So 1 plus 2 equals 2 times 1 plus 1 and see if it works. 1 plus 2 is what? 3. And 2 times 1 is 2 plus 1 is 3. 3 equals 3, so I know I got it right. Okay? And again, I know we don't always have time to do that necessarily, but on quiz tests, for sure you might want to do that, okay? Okay, let's do one more together, and then I'm gonna let you guys try one on your own, okay? So we're gonna skip down here to number 3. You ready? Okay? So this time, I'm gonna just do all the drawing instead of the actual tiles, and then we'll record, okay? All right, so which side, which X's am I gonna move? On the right, because there's less of them, right? So to get rid of it, I need to bring in a negative X. What I do to one side, do to the other. Did I create any zero pairs? Yes. Mark them out. Okay. So now, what do I have over there with my X? I have negative 5. So how do I get rid of negative 5? Bring in positive 5. I just draw circles because I find them easier to draw. And I understand that they're the same. And what I do to one side, I do to the other. Did I create 0 pairs? Yes, all of those are, but what about over here? Not all of them. I'm still left with. So now what's my answer? X equals -2. Perfect, bless you. Okay, now let's come over here and do it algebraically. So what does the left side of our equation say? Plus -5 or -5, either is the same, equals x minus 7. Okay, there's our original equation. Okay, so now you can see between 2x and 1x, which one is smaller? Minus, so we're going to subtract x from both sides. And I'm left with just x over here, bring everything else down. Those are gone, bring it down. Now what? I already have a subtract 5. I need to add 5 because it's negative. So I'm going to add 5 on both sides. And I'm left with x equals -7 plus 5, -2. And if I check it one more time, 2 times -2 plus -5 equals -2 minus 7. I'm going to show you all a really cool thing. In the calculator, if you type in exactly what you see right there, so 2 times -2 plus -5, and then there's an equal sign right here underneath the control. If I put equals -2 minus 7, enter, it says true. So that tells me that this is a true statement, right? If it wasn't, it would say false. And so then I would know, wait, something was wrong. You know what I mean? Or I can use my brain and go 2 times -2 is -4, -5 makes -9, -2 minus 7 is -9, and it works, right? But I know y'all are like itching to use these calculators more. I know you are. Okay? All right, do you feel like you can try this middle one by yourself? Try to solve it with the model and then algebraically, okay? If you're home, pause the video. Okay, you should have gotten x equals 3. Now, when you look at my model, like you didn't watch me do it, but now you're watching that it's done, it looks like a hot mess, right? I mean, it does, and so does yours. I mean, it looks probably good to you, but somebody else coming behind you, it's kind of a mess. So again, that's why we want to make sure that we're also doing it algebraically, because hopefully everybody's algebraic looks similar to mine, right? And we talked about this yesterday, how eventually you're probably going to stop writing down some of these steps, but for right now, I highly advise against that, okay? Does anyone have any questions so far? We okay? Okay, let's turn the page. We're going to get a little spicier. A little spicier. Okay, I think we're good with number 4. Let's go down here to number 5. All right, so number 5 got a little spicier because it now has parentheses. So let's draw, and this one also doesn't have a model drawn for you. We actually have to create our own model. So on the left, what do we need? 3x plus 6. Okay, now on the right, you will not draw parentheses. What does the parentheses mean? Right? But what does this actually mean? What am I going to see over there? Okay, so I hear some things. I heard some people already go ahead and distribute it out. But if I wanted to say, what I actually see over there is, okay, so like, I want you to think back to your 3rd grade self. When your 3rd grade self learned how to do that, learn how to do 2 times 3. Trey, are you with me in your 3rd grade self? All right. What did you learn? Way back. The multiplication was just what? Grouping, that's the word I was looking for. Say it again. Brent, what's this? So how would you say this? 2 groups of x plus 2. So that means I'm going to go over there and make x plus 2. So here's x plus 2. But I need 2 of them. 2 groups of x plus 2. And you might want to write write that down. And no, seriously, because back in third grade, you would have learned that that's two groups of three, right? So it's two groups of x plus 2. Okay, now, is there really anything different in solving with the model? No, right? It's gonna be backward, back to the same thing. So I'm gonna mess with the little guy, so that's this one. I do the same thing.
I'm the bully, I'm listening to little guy.
0 pairs. Now, with my x, I see 6 positives, so to get rid of them, I need 6 negatives. I do it to both sides. Those are 0 pairs. And I get that x equals -2. Okay. So that was the same. I didn't go to do that? Did I mess up? Okay. But now, let's talk about how it's different here, right? What do you think that we need to do first? So how am I going to deal with those parentheses? Yeah, I need to use the distributive property and go ahead and distribute it out. I know we just talked about on the homework, on this one, where we said, oh, let's just go ahead and divide. But what do I have here that I don't have on this problem? Yeah, this was just a whole number, right? Well, I mean an integer. But here, I can't just do that with this. You see what I'm saying? Because I've got an expression sitting over here. So instead, let's go ahead and distribute it out. 2 times x would be 2x, and 2 times 2 would be 4. And now it looks like the ones we were doing on the front. So what are we going to do next? Minus 2x. Then what? Minus 6. And I still got x equals -2. And there's my thought. Okay? All right. How about you guys try number 6? If you're at home, pause the video. Okay, so we started it out 8 plus x and then 3 groups of x plus 1, and we decided that we needed to do that, okay? Do you have your x's by themselves? Yes, but we don't have 1x, but we're going to hold on for just a second. I have my x's by themselves. Now, I need to get rid of these so that I can have, again, just my x's by themselves. It's good to have all your x's by themselves. Okay. So now, I'm still not done because what are you looking for? The value of a single x. But right now, I've got that 2 x's equal what? 5. So then that means that 1x must have the value of, exactly, I could cut it. And so these guys belong to him, and these guys belong to him, and so x equals 2.5. Okay, now this is obviously where you couldn't do it with the tiles themselves because you can't break them, but we could do it with our picture. And if you'll remember, we did this with one set of equations last year. Okay, let's do it algebraically where I feel like you're going to be more comfortable. First, we distribute 3 times x would be 3x, 3 times 1, 3, bring this down. Now what? So minus x, 2x plus 3. Now what? You see how now when it was algebraic, you knew exactly what to do with it. You just weren't quite sure when it was a model. And then what? Divide by 2. So x equals 2.5. Okay? So sometimes the numbers are not going to be nice and pretty. But it worked out, right? I do really quick want to talk about, and I don't know. Okay, so you know in the beginning when I said you'll want to move your smaller one, well, what if you don't? What if you just like made a mistake and instead you started with this one? So what's going to happen? So if I minus 2x plus you to get rid of that, and I minus 2x over here, These are gone, I'm left with 1, but what is this now? Negative x plus 2. Now what? Some of your eyes aren't red. Now what? Subtract 2 on both sides, right? Negative x equals negative 1. Yeah, if I just divide or multiply by negative 1 here, that eliminates my negative, and I still get that x is 1, which is what we got in the first place. So the only problem was it added an extra step. So it's not wrong if you start with the wrong side, the quote wrong side. It's just that you're going to have a negative x variable at the end, and so then you're going to have to fix it. So it's not wrong, but I just always say try to start with the smaller variable, whichever one is smaller. Okay. All right. I think is that all the problems? Or was there one left?
No, there was one more, number 4.
Oh, next page. Next page. Okay. Now let's do number 7 together. You ready? Okay, so let's say it out loud. What does that word say?
3
That's right. So we need x minus 3. And I need it 3 times. That's what's on the left. On the right, what do we see?
4 groups of x minus
4 groups of x minus 1. I don't know about you, but I'm like, hey, but I've been very used to that. This looks like a lot of fun. Okay. Okay. I admit it. I totally admit it. Okay. So now I've got my model drawn. So which one am I going to work with first? The left. That's right. So I've got 3 positive x's, so I need to bring in 3 negative x's. And then what I do to one side, to do to the other. Okay, 0 pairs. And so I am left with only 1 x. That's good. I don't have to do any splitting. Okay, now what do I need to get rid of? These 4 negatives by doing what? Bringing in 4 positives, which I'm going to do on both sides. So that zeroed all of those out. And what is left on the left? Negative 5, and on the right, x. So x equals negative 5. Okay, now let's do it algebraically. What do I need to do first? Distribute, that's exactly right. So 3 times x would be, hello? Thank you. Hey y'all, do you draw these little things at the top?
No.
We learned that last year. That's just reminding yourself, because what do you think kids forget to do here a lot? That's right, or distribute to the second number. A lot of y'all will put 3x and then put minus 3. You forget to distribute that second number, so be careful. So 3x minus 9, and then this side will be?
4x minus 4.
Perfect. Now what?
Minus 3x.
Minus 3x. Now what? I'm sorry, what? Plus 4, which would be negative 5. Now, wasn't that one a lot easier without the model? Totally, right? Okay, so there's one more here left to do. You guys try that. Pause the video. Where you're going to match the model, but then you still have to solve it, y'all. If you just want to solve under here and not with the model, and then so basically like you would say this connects to this, connects to this. I mean, that's probably not right, but you're just going to make a match, okay? It shouldn't take you very long. There's only 5 questions, and now you've learned everything that's going to be on the test, okay?